Good morning, students. I hope you had a very nice weekend. Yes, this morning I want to take you through hypothesis and hypothesis testing. So, in one of our last lectures, we discussed about, I gave you just a broad overview of what hypothesis is, and I told you that I was going to give you a comprehensive presentation on hypothesis and hypothesis testing, and that's why we are here this morning. So I start with the definition. A hypothesis is a proposition or guess statement which can be put to test to determine its validity. It may seem contrary to or in accord with common sense. Hypothesis is therefore an attempted explanation or a sort of possible research outcome which may be confirmed or rejected at the end of the study or at the end of the analysis. Hypothesis testing in research involves the scientific consideration of the condition under which the research questions can be answered. Research questions are usually turned into some form of operational statement. These operational statements, called hypotheses, are based on some theoretical postulates or some assumptions concerning the concept of the research. That's according to Adana 1996. So what we are saying in essence is hypothesis is a guess statement, is a speculation about the relationship or assumed relationship that you have between any two variables or between a variable and a set of variables. In quantitative analysis or quantitative techniques, the hypothesis that is usually posed is referred to as the null hypothesis, HO. The null hypothesis posits that there is no significant relationship between the variables or bodies of data or groups under investigation, even though the raw data might give the impression that there is actually a difference. Of course, the assumption there is that a member of staff with a high socioeconomic status tends to have or to go for or to have preference for a standard housing accommodation that can accommodate his family members, that will provide a very serene environment, that have all the facilities. Whereas a junior staff or someone whose status on the campus is not quite okay may be comfortable with just a room or a room and parlor self-contained. So what we are saying is that based on the on what we already know, that your socioeconomic status tends to determine the type of accommodation that you request for. That's what informs that type of hypothesis. A null hypothesis may be stated that there is no significant difference between the ages of building in Maseru district and those of buildings in Berea district. I think I have mentioned that. We have what we call in statistics, we have directional and non-directional hypotheses. Directional and non-directional hypotheses are posed for one-tailed and two-tailed tests respectively. So what do we mean by a two-tailed and a one-tailed test? A two-tailed test is a test meant to test how significant two bodies of data or situation differ from each other, while a one-tailed test is used to test how significantly higher or lower, better or worse is a situation than the other. In other words, there is an assumption or clarity about one situation relative to the other in a one-tailed test, while the opposite is true for a two-tailed test. For example, if it is stated that there are no significant differences between the ages of buildings in Maseru district and those of buildings in Berea district. So if I ask you, what type of hypothesis is this? Is it a one-tailed or two-tailed? Is it a directional or non-directional hypothesis? If you look at it critically, it's only testing whether there are significant differences. It doesn't have any direction. So that is a typical example of a non-directional hypothesis. If, however, the researcher is interested in knowing whether or not buildings in Mafeking are significantly more aged than those in Berea, the test is a one-tailed test because it is already directional. Because what you are saying in essence is that based on your knowledge of that place, that buildings in Mafeking are relatively more aged than buildings in Berea. So that's the assumption there. And that will give you an idea of the fact that you need a directional hypothesis, which will state that ages of buildings in Mafeking are not significantly higher than those of buildings in Berea. The critical value which determines the decision to accept for the two cases will also differ. So there could be many other examples. For example, we can have hypothesis stated thus: rent of NUL staff housing is not significantly different from house rent offered by private real estate investors. This is a non-directional hypothesis. It's a two-tailed hypothesis. It is not directional. Of course, you can as well have rent of NUL staff housing is not significantly cheaper than house rent offered by private real estate investors. This one is a directional hypothesis because there is an underlying assumption that there is every tendency that our staff housing offered by NUL is likely to be cheaper. But now you only want to test whether the rate at which is cheaper than the other one is significant or not. So another one could be it should be noted that while rejection region is found on both sides of the curve in a two-tail test, it is on only one side in a one-tail. So now, how do we then proceed? What is the procedure in testing hypothesis? And that has led us into steps in hypothesis testing. And we want to borrow from the work of Okoko 2000, who has identified the following procedure. And the first step, according to him, is that you define the population of interest to be investigated. You don't just do any study. And even when we are talking about statistics data, of course, that data will be meant for a particular place or a particular population. So the population of interest must be well defined in order for you to have a good knowledge of what you are talking about and for you to be able to understand the process. So the next thing is take a random sample of this population. We all know that we have quite a number of constraints in the process of doing our research. So meaning that it's always impossible for you to actually cover the entire population, especially in urban planning, in urban geography, where we deal with human population, built environment, town, cities. So we just must take samples. So you take a random sample of this population. So after which, the next step is you formulate the hypothesis to be tested. After formulating the hypothesis, which you have seen the way we have been formulating the hypothesis, the next step is choose a suitable statistical test. This suitable statistical test, based on your knowledge of statistics, it could be any one of them. It could be t-test, it could be chi-square, it could be correlation, it could be regression, depending on what you are looking at. Then once you have decided that, the next thing is to compute the test statistic from the data collected. The statistic thus obtained is called the calculated value. So the next one, which of course might have come earlier, but the next step according to this procedure we are looking at is specify the significance or alpha level. This is usually at 0.05 or 0.01. Although the statistical table also has 0.1 and 0.001 among others. The values that correspond to these levels are different degrees of freedom when looked up for from the computer-generated set of values, usually at the back of statistical textbooks, are called critical values. So a choice of 0.05 alpha level means that the decision on the null hypothesis has a probability of 5% or 0.005 of being wrong and 95% confidence level. So what do we mean by this? When you say that you want to carry out your test at alpha equals 0.05, it means that the probability of committing type 1 error, if you must do that, is just going to be 5%. So what we mean by this alpha level is nothing but the probability of committing type 1 error by the time you are taking a decision on your null hypothesis using the 0.05 alpha level. And just like the opposite of it, if 0.05 is the alpha level, which is the probability of committing type 1 error, then if you take it from 100, 95% confidence, then you have 95% as your confidence level. So thereafter, you reject or accept the null hypothesis since you already know the level at which you want to take the decision. The rule is that when the calculated value is greater than the critical value, the null hypothesis is rejected and vice versa. If, however, we need to take note of this, if the computer is used to carry out the test, there may not be the need for you to check the critical value. The computer will provide the probability of rejecting a true null hypothesis, that is, the alpha level at which your result is correct, at which you can reject the null hypothesis. So the probability of which is the probability of committing type 1 error, like I said earlier, and according to the computer output, it is denoted as SIG. So wherever you see SIG, the value that you see there is giving you alpha level, and that's the probability of committing type 1 error if you reject the null. So note, however, that the examples above are for quantitative data or quantitative research. When qualitative data are involved, hypothesis testing is not always emphasized, but when it is, series of arguments and content are analyzed with content analysis and discussed accordingly to arrive at a conclusion or conclusions to determine whether the hypothesis is rejected or accepted. Distinguished ladies and gentlemen, we have come to the end of this class. I hope that you've had a nice time listening to this lecture. And in case you have any question, do not hesitate to ask. You can put the question across to us through the appropriate platform, and I'm going to get back to you. I wish you a very nice day today, and I wish you also a productive day. Please stay blessed.